right.
Okay, you're good.
Okay, so for number 1, it's asking about the 4 viruses and whether it's RNA, DNA, single-stranded, double-stranded, and then circular versus linear. So first we did the circular versus linear. So up here, right here, I wrote down which one was which. So the endo ends up being circular, while exo is linear. So the first virus and the last virus is endo, so they're circular, sorry. And then virus 2 and 3 are linear. And then for the next part, RNA and DNA, you can tell by what it gives you up here. So if it's, so for number 1, T is at 0%. So it has to be RNA because it's only used in RNA. 2, we have also RNA for the same reason. And then 3 and 4 are DNA because the U is 0% in both. And then for double-stranded and single-stranded, you compare the percentages of the nucleotides base. What are those? The bases that match. So A and T should be pretty close to each other. And in the first one, it is, well, A and U. So 28 and 26% are pretty close, so it's double-stranded. Virus 2, A and U are 34 to 15, which are not close, which means it's single-stranded. 3 is A is at 20 and T is at 18, so it's double-stranded. And then 4A is at 18, while T is at 25, so it's single-stranded.
Okay, so for the vocabulary words, we got for A, and then for the first blank, we got topoisomerase 2. And then for the second blank for A, we got nucleosome. And then for B, for the, I don't have the DNA double helix is 2 nanometers wide, and then the adjacent base pairs are separated by 0.34 nanometers. And then for C, that topoisomerase 1 introduces positive supercoiling. And then D, the origin of replication for E. coli is auric. And then E, the bacteriophage 2T proteins were 35S, while the bacteriophage 2T DNA was 32P. And then for F, the sugar in uridine is ribose, while the sugar in deoxythymidine is deoxyribose.
Okay, we good now? Yes. Okay, so I have number 3. And for number 3, it's talking, it says, suppose the translocation occurs between chromosome 14 and chromosome 21 in an individual. A translocation is the result of a fusion between 2 non-homologous chromosomes. Chromosome 14 is 109 million base chromosome, 21 is 48 million base pair in length. For this problem, assume that the translocation fuses entirety of chromosome 14 to the entirety of chromosome 21. So A says, how long is the DNA portion of this translocation chromosome in meters? So for, let's see, can you guys see? Yeah. For A, we were able to, what we did was 109 million, and we added it to the 48 to get 1.57 times 10 to the 8th base pairs. And then we multiplied that by 4 nanometers over 1 base pair, and then times that by 1 meter over 10 to the 9th nanometers. And then that equals 0.05 meters. And then B, it says how many nucleosomes are found within this translocation chromosome. Assume the average length of the DNA is 50 base pairs. So from there, we take our 1.57 times 8 times 10 to the 8th base pairs, and we multiply it by 1 nucleosome over 196 or 197. And so from there, we got 8.01 times 10 to the 5th, or 7.96 times 10 to the 5th. Or if it's supposed to be a range, it'll be between those two numbers. And then C, it says how many H2A molecules would you expect to find within this translocation chromosome? And so C's right here. And it said, so we do 1.57 times 10 to the 8th base pairs. And then we multiply that by 1 over 196 or 197. And we multiply that by 2 over 1. And 196 or 197 both equaled around 1.602 times 10 to the 6th. And then D, and it says how many radial loop domains would you expect to find within this translocation chromosome? And so we took 1.57 times 10 to the 8th base pairs, and we divided, multiplied it by 1 radial loop over 25,000, in the range of 25,000 to 200,000. And so that gave us the range of 6,280 to 785 radial loops. I don't know why we didn't just would have been.
Okay, so for number 4, they're wanting to know about the bacterium Mycobacterium tuberculosis. It has a singular circular chromosome that is 4.41 times 10 to the 6th base pairs in length. So for A, it's wanting to know if it was stretched out linearly, how long would it be in micrometers? So we know how many base pairs they have, and we know that each base pair is separated by 0.34 nanometers. And so we want to have it converted into micrometers. So we do for the number of base pairs times 3.4 times 10 to the negative 4th micrometers, and we get about 1,500 micrometers in length. It's like 1499. So for part B, they wanted to know what the diameter is, and because we just found out how long the chromosome is when it's stretched out, we know that that's the same as the circumference. So we just manipulate the formula given in the equation or in the question, and we do 1,500 divided by pi, and that gives us our diameter of 477.2 micrometers. For C, we have a loop domain that has 50. So if one of these loops was stretched out linearly, how long would it be in micrometers? So again, we just do base pairs times 3.4 times 10 to the negative 4 meters, and we micrometer. For D, they want to know how many histones are found attached to the bacterium, 4,410,000. The one nucleosome over 196 to 197 base pairs, and you multiply that by 8 histones. So ultimately we get 180,000 histones on the chromosome.
All right. For number 5, the question concerns the structures of nucleosides and nucleotides. Consider the following molecules, A through F. So these are these guys here. Which of the following are nucleosides? So a nucleoside is a pentose sugar attached to a purine or pyridine. And so just those two. If it has a phosphate, it is a nucleotide. So A here is not attached to a phosphate, so it's a nucleoside. B has phosphates, C has phosphates, D has a phosphate, E does not have a phosphate, so it is also a nucleoside as well as F. So the answer to the first part is A, E, and F. The opposite of that is nucleotides. They have 1 to 3 phosphates, so that's D, C, and B. The next questions, which contain ribose. So ribose, you'll look at the 5 or the, I think it's a 2 carbon actually, the 2 carbon right here to see if it has a hydroxyl group, an OH. If it has an OH, it's ribose. If it does not have an OH, it is deoxyribose. That's the deoxy. So for ribose, on the 2 carbon right here, F, E, C all have an OH, a hydroxyl group. So those are all ribose. Controversially, A, B, and B do not have a hydroxyl group, so they are ribose or deoxyribose. And then which contain pyrimidines? The pyrimidines are the coming off the sugar. You have a ring up here, and it'll either be bicyclic and have 2 rings, or just have one ring. So pyrimidines are ones that just have 1 ring. So that's F, E, D. The other ones, as you can see there, have 2 rings.